All right, Chapter 9, Algebra 2, second semester, cumulative review. What happened here? Sorry, technical difficulties. All right, so graph these. So 2x minus 6, we're looking for the solution to the system, so where they cross. So 2x minus 6 has a point right here. That's your y-intercept at -6. Why is this not working? -6. Okay. And a slope of 2, which means up 2, right 1, up 2, right 1, up 2, right 1. You just keep going. And the more dots you put, the more accurate your line will be, and the better chance you have of making sure that you hit everything. Down 2, left 1. Okay. I'm going to do my best on here to make a straight line. That's about the best I can do. All right, my next one is -3/2 x plus 8. So that's going to have a y-intercept of 8 up here. And then down 3, right 2. Down 3, right 2. And there is my intersection right there. And that's a horrible line, but we do see where the intersection is right there at 4, 2. And the nice thing is, I can plug this point in here and here and confirm it. So 2 times 4 is 8, minus 6 is 2, check. -3 times 4 is -12, divided by 2 is -6. 8 minus 6 is 2, check. All right. Now an inequality, x minus y greater than or equal to 8. This one I can do the cover-up method on. Now you gotta be careful with this one, don't just assume anything. So here, -y is -8, which means y is +8. Because you have to divide by -1 to get that. And then if we cover this up, x is -8, which is over here. Now the thing is, without getting a slope, you need to be careful to make sure that you get a really straight line. And I did not mean to do that. I meant to get this, which should have changed it to a, there we go. I want to try to get the best straight line possible. Okay. Now, for this one, I need to test a point. I'm going to test 0, 0 right here. So if I plug that in, I get 0 is greater than -8. True or false? That's a true statement. So I'm going to shade on the side where I got a true statement. So this is the area that I'm shading. Okay. Now for the next one, I'm going to do the cover-up method again because 3 and 1 both go into 6. So y is -6. Okay. And if I cover up this, divide by 3, x is -2. Draw my line. Now I'm going to again test 0, 0, because it didn't go through. 0 is less than or equal to -6. That is a false statement. So I'm not going to shade where that red dot is. I'm going to shade on this side. Now, where is my area of my answer? It's this right here. That's my area. And if it says name 2 solutions, just pick anything in that area. Okay? So for example, you can't, see it very well, but, anything on the axis. Very simple. -6, 0. -4, 0. -4, -3. Down here somewhere. Okay? Anything in that shaded area would be fine. Okay? Solve the system using elimination. All right? Elimination means I need to eliminate one of the variables. So I need to find out 3 and 4, a common number, or 2 and 6, a common number. So for x, I would need negative 12 and positive 12, which would mean multiplying this by 4 and this by 3, and one of them would have to be negative. Doesn't matter, as long as I get negative 12 and positive 12. That's one option, and it's a perfectly fine option. But another option is 2 can become 6. So if I just multiply this by 3, I'm going to get positive 6, which is opposite of negative 6. I'm good to go. Now, is one method better than the other? No. Is this more efficient because I'm only multiplying one time? Yeah, less work I do, the more chance I have of not making a mistake. So 3 times 3 is 9x. 3 times 2 is 6y. And 3 times 25 is 75. When I add these together now, the y's cancel. And I end up with 13x equals 143. And when I divide by 13, x is 11. Now I can plug that 11 in here or here. Doesn't matter. Okay? I'm going to plug it in this first one. 3 times 11 plus 2y equals 25. So that's 33 plus 2y equals 25. 2y equals negative 8. Y equals negative 4. So that is the point 11 comma negative 4. That has been solved by elimination. Use substitution. Well, in this case, we want to solve for extra y. I have a y already by itself, so that's less work. I could solve for any of the other variables, but I would have maybe some fractions or more work to do. This one, I just have to move this over and say y is equal to negative 5x minus 41. Then I'm going to take this and plop it in right here for y. Be careful that this is a negative 3 and put parentheses. Notice now I have all x's. So 2x, negative 3 times negative 5 is plus 15x. Negative 3 times negative 41 is positive 123. $15x plus 2x is 17x. And if I subtract 123, I get negative 136. And if I divide by 17, x equals 8. Now I'm going to plop it into this one because there's nothing to do with the y once I do it. So 5 times 8 plus y equals negative 41. It would not have been bad or wrong to put in the other one, but then I'd have an extra step of dividing by negative 3. So why create the work? So that's 40, which I'm going to subtract to give me y equals negative. Just made a big boo-boo. This should be negative 8. Silly me. Which makes this negative 40. When I add 40 to both sides, that's going to give me negative 1. I could have also just put it in here and done negative 5 times negative 8, which is 40, minus 41 is negative 1. Either way, so that gives me an answer of negative 8, negative 1. Okay, solve using either one. It's your choice. This would be an easy one to solve for y. You can move this over and then move this over and get y equals 2x minus 15 and substitute that in there. Okay, that is one way to do it. Nothing wrong there. If you did that, I'll just do it real quickly. That would give you negative 8x plus 4 times 2x minus 15 equals 10. This would give you 8x minus 60. Okay. And 8x minus 8x would end up being 0. So you end up with a statement of negative 60 equals 10, which is a false statement. So no solutions. That's one way to do it. Otherwise, you could also say I'm going to multiply this by 4. And that's going to give me 8x minus 4y equals 60. I don't know why I just drew that line. And then the negative 8x plus the 4y equals 10. Add these together, that cancels. 0 equals to 70, which is also not true, which will lead me to my answer of no solution. Okay? Because they're parallel. All right, same thing here. I can do whatever I want. I would not go for a substitution here because all my x's and y's have numbers, and I'd have to divide and get some nasty fractions to deal with, and it's just too much work. So I need to pick, do I want to do 9 and 6, which the smallest number there would be 18 and negative 18, or 4 and 6, 12 and negative 12. It doesn't matter. It is really not much more work either way. I'm going to go just smaller, so I'm going to go 12. So if I multiply this by 3, I'll end up with negative 12. And I might multiply this one by, nope, not 4. Math is hard. 2, I'll also get negative 12. So I need to have one of these be negative. It doesn't matter. I'm going to pick that one. Just random. So negative 3 times negative 6 is negative 18x. Negative 3 times negative 4 is going to give me that positive 12y I was looking for. And then negative 60. Remember to make sure you multiply both sides. Don't leave that 20. Common mistake. Then 2 times 9, that's 18x. And I'm going to get 12y. No, minus 12y. Sorry. Whole point of doing this. Minus 12y equals positive 60. Now when I add, well, that cancels, that cancels, that cancels. I have nothing. Well, I don't have nothing. This is 0 equals 0, which is a true statement. So my answer is infinite solutions because these are the same lines. All right. Solve this one using a graphing calculator. So we're going to first set up our augmented matrix. We already have our x's, y's, z's, and numbers lined up, so we're good to go there. This is what we're going to enter in our calculator. Negative 1, negative 5, negative 5, and 2. 4, negative 5, 4, and 19. 1, 5, negative 1, negative 20. Okay? So we pull up our graphing calculator. Hopefully it works. There we go. So remember, the quickest way we figured out how to do this now is hit second matrix, go over to math, go up to RREF, B. At this point, hit alpha zoom. Now, how many rows are there? You can just see there's 3. So I'm going to go over here and hit enter. There's 4 columns. So I'm going to go down and hit enter. And I'm going to hit down and hit OK. And here's my matrix. So I'm going to hit negative 1. Now remember, don't hit enter, just arrow over. Negative 5, I'm double checking as I go. Negative 5 and 2. Don't hit enter. Just arrow down. I can arrow over also. 4, arrow over. Negative 5, arrow over. 4, again, arrow over. 19, arrow over. 1, 5, negative 1. See, my 1 didn't pull up. So I'm going to hit it again. There we go. And negative 20. Now I hit enter. And there's my answer. Negative 2, negative 3, 3. Negative 2, negative 3, 3. X, Y, Z. Easy enough. All right, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 the second day by selling 3 senior citizens and 2 child tickets. Find the price of each. Okay. So we just pick, we'll use any letters we want. I'm just going to use X for senior citizen and Y for child. Okay. Now, we have 2 situations here. So we have 3 senior citizens and 1 child. That's 3X plus 1Y. And that brought in $38. We're comparing 2 situations. And then the next day was $52, 3X, and 2Y. Now at this point, you can do whatever you want. You can even put this in the calculator and have the matrix do it for you. You'd put in 3, 1, 38, 3, 2, 52. It's a 2 by 3. Very easy. But also, elimination works really great here. I can literally just multiply the top one by negative, like so. Everything by -1. Add them up. That cancels. I end up with 2y minus 1y is y. And 52 minus 38 is 14. Okay. And then if I substitute that in right there, subtract 14, divide by 3, I get $8 for a senior citizen and $14 for a child ticket. And again, you could have real quickly done this. Second matrix, math, go up to RREF. Even if you were on the test have to pick a method, you could do this to make sure you did it right. Alpha zoom. This time it's a 2 by 3. And put in 3, 1, 38, 3, 2, 52. Enter. 8 and 14 right there. So even if nothing else, just to double check your work. Let the calculator do all it can for you. A total of 925 tickets were sold for a game for a total of $1,150. An adult ticket sold for $2, child ticket for $1. So again, we have, I'm going to say A for adult and C for child. Okay. So there were 925 tickets sold. That means the number of adults plus the number of children was 925. It was $2 for each adult ticket. It was $1 for each child ticket. And they made $1,150. Okay. This would be a really easy one for substitution. Okay. This is also a very easy one for elimination because, again, I can just multiply by -1 here, add these together, and my C's cancel. 2A minus A is right there, 1A. 1150 minus 925 gives me $225, or 225 adults. And if I plug that in for A, subtract it from 925, that gives me 700 child tickets. And that's it. Right. Washer and dryer manufacturer wants to maximize the profit on 2 products. Right? A washer yields a profit of $230 per unit, and dryer is $150 per unit. Okay? So just for the heck of it, I'm going to use W and D, washer and dryer. All right. So the profit, the objective function, is 230 W plus 150 dryer. That's my Z. Okay. List all the constraints. Immediately, I just put this. Immediately. Put them. Now, market tests and available resources indicate that combined production level should not exceed 150 per month. So washers and dryers total, just together, should be less than or equal to 150. Because of demand issues, the manufacturer must carry between 20 and 100 washers at one time, at all times. So this is a little different than we've had before. So they have to have at least 20, and that is washers. So that's my W, okay, or my X, whatever. So W, and we have W here and D here, okay? W must be greater than or equal to 20, and W must be less than or equal to 100. Okay? So W and D is 150. So that means basically I'm going to have a dot here at 150 and a dot here at 150. I do the cover up method, and there's my line. I'm going to test 0, 0. 0 is less than, whoopsie. 0 is less than or equal to 150. That's a true statement. So I'm going to shade everything down here. Then W, or my X, must be greater than 20. And less than 100. So that means like that. And for the 100, like this. So where is my overall area? It goes from here to here to here to here. That's my area. So what are my corner points? My corner points are 20, 0. 140, 0. Wait, hold on. 100, 0. Sorry, 100, 0. 100, comma 50. That's this one right here. And this one right here at 20, 130. I'm going to run all those through this one, plug them in. For this one, I get 4,600. For this one, I get 23,000. For this one, I get 24,100. And for this one, I get 30,300. Oh, my bad. I did those backwards. Sorry. The 100,550 is the 30,500. I think I said 300 before. And this is the 24,100. So my winner is right here. 100 washers and 50 dryers. And the maximum profit is 30,500. Last one. Okay, this one, not even a story problem. This one's already done for you. So X is greater than or equal to 3. So 1, 2, 3, that's right here. Okay. X is greater than or equal to 3. So I'm going to shade this way. Y is greater than or equal to 2. Which means I'm going to shade this way. 2x plus 3y is less than or equal to 30. So I'm going to put color method. Y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Connect those dots. Has to be perfect, like so. Not sure if it's going to matter, but notice I do have an intersection right here. We'll see if that matters later. And right here. Okay. And I'm going to test my points with 0, 0. So 0 is less than 30. True. So that's going to be everything under this line. And then last, 1/3 x plus 4. So 1, 2, 3, 4. Point right there. And up 1 right 3. 1, 2, 3. Another intersection. 1, 1, 2, 1, 2, 3. Another intersection. So I'm just going to freehand this one right here because I already know my points. I'm going to test 0, 0. 0 less than or equal to 4. That's true. So I'm coloring this way now. And so I'm looking for my area of intersection. And that's going to be right here, right here, right here, right there. Okay. So what are my points of intersection? They are at 1, 2, 3, 2. And at 3, 3, 4, 5. And then 12, 2. And this point right here, 1, 2, 3, 4, 5, 6, 6. Now, when I plug those into this objective function right here, I get 8, 2, because remember I'm subtracting, 40, and 12. So there's my winner. The max is 40 at 12, 2. And that's it for this chapter.